Welcome everyone. I am Teacher Navi.
And Teacher Joe. And for today's video,
We're going to discuss the chapter 10 heredity, inheritance, and variation. But first, let me read to you the introduction of this chapter. In the 1800s, explanation of heredity was attributed to a blending type of inheritance, like mixing two watercolors in class. So when we say blending, it is the action of mixing or combining things together. So the resulting offspring is a mix or a blend of two parental forms. This idea did not stay for long, and scientists thought about a possible particulate theory of inheritance. And when we say particulate, it is relating to or in the form of minute separate particles. This gave rise to the idea of kin. These great heritable units retain their identities in the offspring or they may interact, resulting in the numerous combinations. An organism is therefore like a shuffled deck of cards with unlimited combinations of genetic traits. So Gregor Mendel, he was a monk who studied in the University of Vienna, and there he was influenced by Christian Doppler. The latter emphasized learning science by experimentation and trained Mendel to use the laws of mathematics to explain natural phenomena. Mendel went on to become assigned in a monastery where he took a particular interest in breeding garden peas. He noticed that the garden peas appeared in contrasting forms. For example, like flower color was either purple or white, and seed shape was either wrinkled or smooth. He recorded carefully all his observations and quantified the proportion of percentage of the resulting garden peas in his breeding populations. Here, he discovered the laws of inheritance.
so for our learning outcomes, at the end of this chapter, the learner should be able to first is to describe the early experiments of Gregor Mendel. Second, define terms in genetics. Third, differentiate monohybrid in the hybrid process. And last, give examples of pleiotropy, epistasis, and multiple alleles. So he is Gregor Mendel. Uh, Gregor Mendel is a monk who studied in the University of Vienna, and there he was influenced by Christian Doppler.
Now let's move on to monohybrid cross. In monohybrid cross, one character is involved, which is the flower color, but existing as two alternatives. Any character is coded by a set of genes or a gene pair located in chromosomes. So here in monohybrid cross, we have a figure here. So this letter P in this figure represents as the parental generation. And the F1 here is the first offspring generation, and the F2 here is the second offspring generation. So let's see first this genotype. The color purple flower genotype is represents the double letter A's, while while in this color white flower, the genotype is the small letter A's. So in order to get the result of the first offspring generation, we're going to use the Punnett square. So before that, let me read the definition of Punnett square. So the Punnett square is a square diagram that is used to predict the genotypes of a particular cross or breeding experiment. It is named after General Reginald C. Punnett, who devised the approach in 1905. The diagram is used by biologists to determine the probability of an offspring having a particular genotype. So, in here, in order to get the first offspring generation, we're using the Punnett square. So, here in Punnett square, we have now, as we can see here in along with the parental generation, we have a Punnett square here, where the genotype of purple flower can be placed to the left side of the square in the Punnett square, while the genotype of white flower located in the upper part of the Punnett square. So, in order to find the result, to proceed to the first offspring generation, we're going to cross using in the L method from the first genotype of purple flower to first genotype of white flower. The genotype of first purple flower is big letter A crossed into the small letter A, which is the genotype of white flower. So we have the genotypes here. Now we're going to see the first offspring generation. So in first offspring generation, this is the result of the parental generation. So in order to proceed again to the second offspring generation, we're going to use a Punnett square to cross the genotype of each flower from the parental generation. So here, in the first offspring generation, we have, so as you can see, in first offspring generation, we just have two purple flowers. We get these two purple flowers because all of the result of genotype here has the big letter, which represent the genotype of purple flower. So here, we're going to proceed again to this first offspring generation. We're going to use the Punnett square to get the result of the second offspring generation. So we're going to cross again these genotypes one by one in order to get the result. Now, in second upstream generation, we get the result of the first. So in second upstream generation, we got the three purple flowers while we only have white purple flower, a white flower rather. Why we have only have one white flower? Because the genotype that represents the white flower is the genotype of small letter A. So we have one letter A here in the small letter, while the rest have the big letter A, which represents of the purple flower. Now, the ratio of this, so the ratio of phenotype, phenotype is 3 is to 1, where the phenotype represents the color or the dominant of the flower. 3 is to 1 because we have 3 purple and 1 white, while the genotype is 1 is to 2 is to 1 because the same pair of genotype here is 1 the genotype of purple and 2 genotype of the blended white and purple flower, which is the one big letter A, small letter A, and one represent as the genotype of white flower. It is pure white flower because this is the original genotype of. Now we're going to proceed to definition of gene pair. So a gene pair has two alternatives, either purple or white, which we call alleles. So in two alleles, alternatives compose a gene pair. So it's a vice versa definition. While the dominant allele determines the appearance or the color, like what I example in the previous slide. The dominant allele in one chromosome or locus mask or hides the expression of the recessive allele at another locus or chromosome position. So when we say recessive allele or recessive gene refers to an allele that causes a phenotype or visible or detectable characteristic that is only seen in homozygous genotype. When we say homozygous genotype, an organism that has two copies of the same allele. So we're going back to our previous slide. So here, the heterozygous genotype, or the homozygous rather genotype, an organism has two copies of the same allele is, so the genotype of the white flower, we can say that it's a homozygous genotype, while the rest that we have a big letter A genotype, we called it as a heterozygous genotype because hetero means marami.
So now let's move on to the Punnett square. So as you can see, Punnett square it consists of four squares. So let's define first the phenotype. So phenotype the outside visible characteristics of the organism, while the genotype is the gene represented by letters. So phenotype is literally known for the visible characteristics of one organism, just like the colors of the flower or the petals or the actual characteristics only of the organism, while the genotype is the gene pair of the organism. So, as you can see, Punnett square is composed of genotype of big letter B and small letter b. So, in this Punnett square, you can see that we get a one big letter B or one pair of the genotype which composed of big letters of B, while the next is two pairs of genotype big letter B and small letter b. And the last part of the genotype is all small letter b, which contains the phenotype of white color. And the rest phenotype is composed of violet. So let's move on to the next. So the next one is the dihybrid cross. So as you can see, monohybrid cross and dihybrid cross is just the same, but it is differentiated from on how it will be. Uh, so dihybrid cross is differentiated on how it would be characterized. As you can see in our picture or figure in our screen, you can see that the hybrid cross is composed of two pairs of genotype. So the phenotype is the round shape yellow and the other is the wrinkled color green. So the monohybrid is just the one pair of genotype, while the hybrid is composed of two pairs of genotype. So let's proceed to the Punnett square. So as you can see, we already have the parental generation, which is the genotype of big letters of R and Y, and the other is a genotype of small letter R and Y. So our first generation is, or the first offspring is composed of all genotype of big letter R and small letter R, and a genotype of big letter Y and small letter y. So the result is all round yellow. So the next part for our second offspring or second generation, we have to divide the first generation into the four levels or the four squares. So first generation divided into one fourth of each table to fulfill our Punnett square. So we have genotype of RY, big, and R, big, and small y. Next is the one fourth of R, small, and big Y. Then the one fourth of R small and Y small. So as you can see or as you can observe in our screen, we have to do the L method to get the result. So big genotype of RY is we have the genotype of RR big and RR Y. So so based on our street, so we have already in our first square, we have the round yellow. So you always do the L method to proceed the result of our gamut. So always remember that in the left part of our Punnett square is the male gamete, while the upper part of the Punnett square is our female gamete. So always do the L method to proceed for the results of our Punnett square. So now, after that we get our result, we have the yellow, yellow round, which is the ratio of 9, Yellow wrinkled, which is the ratio of 3. Green smooth is the ratio of 3. And green wrinkled is the ratio of 1. So all we have in the hybrid cross, we have the ratio of 9 is to 3, is to 3, and to 1.
Now let's going to proceed in incomplete dominance. So incomplete dominance alleles may not be completely dominant or recessive. So these incomplete dominance called disease are like a blending type of inheritance reported by a scientist a long time ago. So here the gene pair of parental types, which is the red and the white color of the flower, they will blend together, the outcome will be color flower. While these three color flower called the heterozygotes because it's called the heterozygotes because it is the combination of two homozygotes, which are the white color flower and the red color flower. We can call this we cannot call this as a hot because pink color flower is the combination of white and red flower. Now, let's proceed to the multiple alleles. So, codominance is when the heterozygote shows the associated homozygote phenotypes. Often you see codominance in molecular traits. The most common type of codominance is associated with blood types, and there are multiple alleles that determine blood type. Now, as you can see, these are in this figure we have here in our screen. Blood, there are blood type A, B, AB, and O. The middle part is the middle part is the process or the crossing of the blood type into the universal type. So our universal blood type is O. So why AB is its outcome is only AB because AB blood type is an independent kind of blood type. It is called the homozygous. So while this blood type A, B, and O can be blended to the universal type or the universal blood type.
So let's move on. So the next is knowledge in compatibility of red blood cells is important. So compatibility. So knowledge on compatibility of red blood cells is important. So compatibility of human blood cells is here we have a blood type of A plus, universal A O plus, B plus, AB plus, A negative, O negative, B negative, and AB negative. So if you are donating your blood, you can give your blood if you have a blood type of A plus. You can give your blood to the A plus and the AB plus. So we all know that O blood type is considered as the universal blood. So that's why O can be compatible to the any type of blood type except for the AB plus because AB plus is the independent one. So if you have the blood type of B plus or B positive, you can receive the blood type of B plus, B negative, universal positive, or universal negative. So always consider the independent and our universal blood. Now let's move on to the pleiotropic and pleiotropic alleles in humans are responsible for the multiple symptoms associated with a particular disease. Next is the recessive. It is an expression of a phenotype by a gene to one gene may alter the effect of another gene at another locus. So phenotype it is the visible characteristics of organisms. Pleiotropic alleles in humans are we consider it are based on our figure in our screen of the possible parents of the first generation or the first offspring, either brown and black rats or the brown or the white rat of the first offspring. So next is the F2 generation or the second offspring. We use the Punnett square to identify the possible outcome or inheritance by the next generation. So as we can see in our screen, we have the first L method of the Punnett square. We have the brown. Next, the next line of the L method for the Punnett square, we have the mix of brown and the black. Next is the brown and the half of the white. Next is the one brown, one black, and the two pairs of the white rat. So it is representation of the genotype. So next is the phenotype of the. So we have the characteristics or visible characteristics of rats that is brown, black, and the white. So in all, we have the ratio of 9 is to 3 is to 4. So now let's move on to the polygenic inheritance. So polygenic inheritance, as Mendel studied, the characteristics that are qualitative, or either it is defined by the characteristics or the descriptive type of the characteristic. It is either red or white, and either round or wrinkled. So also Mendel identified the quantitative as height and human skin color. So quantitative characters imply a polygenic pattern of the inheritance. So the polygenic inheritance is known or identified by Mendel as a quantitative character. So as you can see in our screen, we have the human height, weight, and skin color are examples of the polygenic inheritance. The color of your hair, the darkness of your eyebrows, the color of your eyes, the thickness of your eyebrows, lashes, and either the skin type that you have in the polygenic inheritance. So, so that's it.
A warm thank you to all of you. Again, I am Teacher Rosie and Teacher Joe. Bye!